Hi, I'm Mark Dunlop. This is the first of two videos on a quick guide to user studies. What I'm going to cover in these videos is a quick introduction to user studies focusing on experimental designs. Experiments where you're trying to prove system A is better than system B in some focused way. I can't cover everything in two short videos. I mean, statistics is a degree, so I'm not going to get all that into two videos. But what I can do is give a recipe for running a user study to compare system A versus system B to try and prove something. In this video, I'll look at the study design itself, I'll look at ethical approval, I'll look at the forms and procedures you should follow, logging, timing, videoing. The second video will look at analysis of the data. So what we're interested in, as I said, is comparing different conditions. So you might have the normal condition and your novel better one that you think is better, and you want to prove that it's better. And better might mean faster, it might mean less error prone, it might mean more accurate output. There's different reasons, but you're looking at one specific reason and trying to compare two systems on that reason. You might have two novel systems and you're trying to see, oh, if we implemented this, which would be better? Or you might simply be comparing system A and system B. It's much easier to design experiments and come up with solid answers if you're comparing two systems. You can run most of this work on a single system, but then at the end, all you can say is the results you got for that system. Without a comparison, it's quite hard to tell what that actually means. Whereas if you can say this is better, it's faster, it's more error resistant than a standard system, then you've got a better argument that you've made a scientific contribution there. You can do A versus B, that's what these videos are doing, or you can do more complicated things like A versus B versus C versus D, onwards. A v B is much easier, so that's what we'll focus on. And the particular AVB I'm going to look at is based on my research, which is watch text entry. So I've been looking at text entry for years, and now I've been doing some stuff on text entry on smartwatches. On the left here, we have a very simple port of the desktop keyboard or the mobile phone keyboard. We have a touchscreen keyboard, suggestion bar, and because space is so tight, you end up with a single line for what you've entered. Okay, and the phrase here is not a good sign, okay, which is the end of this longer phrase. Okay, so all you see is the end of it because you've only got space for that. On the right here, we have an alternative. This is a tilting keyboard. And the idea here is that I would rotate my wrist. Oh, it's hard to get that in the camera. I'd rotate my wrist to swap between seeing the keyboard and seeing the text. So I could pick an angle that I was comfortable with and type with it. And I'm just going to use that as a working example throughout this. So we've got the standard or simple, just make it look like a smartphone but miniaturized, versus trying to use a novel sensor to have a layered tilt-controlled version. So first thing you've got to decide whenever you're doing any experiment is what's your conditions. The experimental or independent variables they're sometimes called. In my case, there's two keyboard versions. They differ by tilt and layout only. Everything else is the same. So I've got standard and I've got tilting. Okay? Everything else is the same, including the prediction algorithm and the suggestion bars underneath. So there's no difference apart from that. That's really important because at the end of the study you want to be able to say if you found a difference, it's because tilt is different from standard. Okay? It's not to do with any of the algorithms under the surface. Then you want to do is decide what do you want to measure. So you've got your conditions, keyboard A, keyboard B, and what you want to measure. They are the outcome or dependent variables because they're dependent on your experimental design. In my case, I want to measure speed. Particularly, I'm going to measure speed in words per minute, which is the standard thing from old touch typing tests. So I'm going to measure speed and I'm going to measure accuracy. Accuracy I'm going to define as the backspace usage during typing. So how often do they use backspaces? Typically in user studies on text entry, people type very accurately. and they correct using backspace. So backspace is the main method I'm going to use, but I'm going to just check that they have actually entered a useful string by doing a final string distance comparison to see how far their submissions are to the known answer. Okay, so that's what are your conditions, okay, and what are you going to measure. Once you know that, you can then write your hypotheses. And your hypothesis, if you're having one, is a statement that is measurably testable. Okay, so it's a statement that you hope to achieve, really, and it should be testable. And your study will be designed to support or reject that claim. A lot of statistics work with the null hypothesis. The statistics actually test if there is no difference. Okay, so for my keyboard, my hypothesis will be users will type quicker with the tilting keyboard than with the standard keyboard. Okay, drilling that down, you've got your conditions here, tilting and standard, and you've got what I'm measuring is type quicker, which is speed. Okay, and I'm measuring that in words per minute, and you can explain all that in your report. But that's basically the short version of my hypothesis. And the null hypothesis is typing speeds will be the same between the two keyboards. Okay, so ethical approval. You're doing studies with humans, any studies involving humans. So typically what we're going to do here is get a bunch of people in to type on the watch. We need informed consent. We need to know that they know what they're getting into when they sign up for this and they start doing it. So we have to have informed consent for doing the study, for recording any data in the study, particularly for recording personal data. So if you need to know personal details about them, you have to handle that data very carefully. It's all handled under the Data Protection Act in the UK and similar laws in the EU and further afield. Photography and video, you have to get permission for that explicitly. Again, they're personal data and they're covered by the Data Protection Act, and they're particularly sensitive data, so you have to ask explicitly for it. And participants need to know that they can quit. Okay? You should get ethical approval. You need institutional ethical approval. In computing science at Strathclyde, that Mark Roper handles that. So, and he's got a web page there that guides you through it. You should read over that. One of the outcomes of your ethical approval is a statement that you stick on your introductory form. So here's my introductory form that I use in the watch study. It asks various details, and then it has a section on the ethics. Okay. On photographs, it says the researchers would like to take photos of the study. I give consent, blah, blah, blah. For photographs for research and publicity, I give consent for research only, and I give consent for I do not give consent. Okay. Then it explains what data will be logged, what you'll be doing during the study, and that you can leave at any point, and what happens to the data afterwards. Okay, and that you get the user to sign. Okay, so as part of that, I'm giving these guys a token for taking part in the study, so I ask them for their email address and their home address. That's personal data, as well as their name, which they put right at the beginning. Okay. And at the bottom, they have to sign it. All of that is personal data, so you have to handle that very carefully. Now, you have to ask yourself, do you need any of that data? Do you actually need to know their name? Do you need to know their email address and their home address? The answer is probably not, unless you're giving out tokens. So you could just skip that and keep everything purely anonymous, with one hint, with one glitch, that you have to get a signature to say that they've agreed to this. One way of doing that is to avoid the signature with an on-screen ethical statement. So here, for example, I've got a phone interface and it says study consent. Thank you for agreeing to take part in the study. The software will do the explanation of what's going on, what I expect from you. You may leave the study at any point. I've simplified this and ruled out the photography because that just makes it complicated. And then at the bottom I have an I understand this page and I'm happy to continue with the study. The user ticks that explicitly, and then and only then they get the continue button. Okay, that's quite a useful way of being able to say that you did have informed consent from everybody, but avoid having to keep a signature and keeping that secure and shredding it at the end of the year. It's increasingly a requirement of research to have data open access. So once you have got your data, make sure it's anonymous, publicize it, make it available open access is a really good technique. It allows others to check your data and check your results are correct. If videos have been approved for this purpose, they can be included, videos and photos. Otherwise, you have to keep them out of the open access data. And it's often actually not really useful, so it's worth just keeping people's privacy a wee bit more. Unless you think there would be a reason for people to analyze the images, just drop them. Right, forms and procedures. So here's a chap up here who's filling in a form. That's how most user studies start. You want to find out some stuff about the user before they start the study. You want them to read the ethics statement and also find out some stuff about them. The standard stuff we ask are gender and age. Do you need that? So for example, in this form here, I've got a gender pick list and I've got an age. And in all cases, you allow people to prefer not to say, just in case they're being private. Okay. Most papers on usability in HCI actually report these. So we recruited 20 participants, 14 female, 6 male, average age 23, brackets 20 to 30 age group, 20 to 30 age range. That is just a check actually for the reviewers and for people reading it that you haven't studied only young men, which is quite common in computing. So it's just a check that there is a reasonable gender balance and reasonable age distribution. You might want to ask their background. So in the paper form that I used, I asked various things that I thought might be relevant to my study. I asked about their eyesight, because I thought there might be an issue with the tilting watch, particularly with varifocals, which I wear. They change your vision a wee bit, so might affect it. So I wanted to find out about people's eyesight. I also thought it might be an issue whether you were left or right-handed, and I wanted people to wear the watch on one hand, on their non-dominant hand, so I asked that. There's a couple ways of typing on desktop, on mobiles. You can tap or you can do this gesture input by stroking the words. So I asked what people normally do. And I asked them how often they wear a smartwatch. This is just background information that you think might be useful. If you've not got a hypothesis about any of these, then it's probably worth dropping them and just keep it very simple. The gender age thing, again, it's unlikely you're going to have an hypothesis that men are different from women, for example, but it's useful in HCI studies to report it just to make sure you've got a good, just to convince reviewers you've got a good spread. Then you have the study interaction sheets. So when I was getting people to do the text entry study, my sheets looked like this. I had explained to them what was to be done, and then I just gave them phrases. So these are the phrases that I want you to type on the phone. Okay, they're short phrases that were actually developed from a mobile collection, mobile phone messages sent on the Enron database. So there's a bit of reasoning that these are the kind of messages people would send from a mobile. So that was my task sheets. So you need entry form, you need task sheets, or you have all the instructions on screen. After the person's done it, it's worth finding out how they got on with it. A lot of that comes down to the logging, but you might also want to fill in a couple of forms. Forms I typically use are the NASA TLX, which is developed by NASA as a task load index. And this was developed for NASA pilots. So after each flight, say in a simulator, they'd fill in one of these forms to say how hard they felt they were working. So ask things like mental demand. How mentally demanding was the task? If you think it's very low mental demand, you tick here. Think it was very hard mental demand, you tick there. And ask about physical, mental, temporal, how successful you were, how your performance was, how hard overall you think you were working, and frustration, how frustrated you were. As a sheet on its own, it's not very informative. but it can be informative in a comparison study because you show that, yeah, okay, maybe they did faster, but they were having to think a lot harder, so it might be more tiring over the long term. The other form I sometimes use is the system usability scale, which asks questions like, I think I'd use this system. It's too complicated. It's easy to use. So people tick these boxes to say how they feel about each system. And you get people to do this after condition A and after condition B. Oh, something really important here. On your study procedures, I forgot to say, you must balance your study. So half the people have to start with system A and half of them have to start with system B. Let's go back to that slide. Mistake, big missing. Yeah, you're comparing system A and system B. You want to be able to tell. I want to be able to tell that the difference is down to the tilting. I don't want a confusion in there that actually if everybody does this system first and then my system, there might be faster in this system just because they've got more experience. Or they might be getting tired by the time they get to my system, so they're slower. Okay, so half the people have to start on this one, half of them have to start on this one. And that's called a balanced study. So after each condition in your balanced study, you ask them to fill out these things, and then at the end you can compare them. Now that's a bit of criticism of using NASA TLX if the user can tell which system you want them to like, and that accounts for the SUS scale as well. So ideally they both look novel and you're comparing them. It's hard to make conclusions in these forms because the user is filling them out, so they might implicit or subconsciously bias towards what they think you want to hear. Good tip is to time, date, stamp all the forms or staple them into a pack. So at the top of all my forms I have a little bit that says for staff use, and I have a date and a time, and if you've got multiple phones going at once, what phone was being used in the study. That just means you can join all the data together afterwards. You don't end up with a form here and a form there and you're like, oh no, whose is this? Okay. And it also means you can tie into the log files, which you'll date as well. So the task sheet should be simple to do tasks that are related to real life but controlled enough to be reliable. I've said that. You enter short phrases. So mine was enter short phrases that were from the Enron collection on the watch, and my task sheet that you can see on the desk there, that great user filling it out, it just lists the phrases that the user is to enter as part of the study. Bad practice to study on yourself, by the way, but it saves a lot of ethical issues about videos. Anyway, logging, timing and videoing. You want to log your data. So as this lovely user was typing away on the watch, I was recording the start time of each phrase, the end time of each phrase. I actually got the watch to do the calculation of the words per minute and output the number of backspaces were used, and do a comparison to the prompt, so how close it was to the final phrase. Because one of the things you've got to be thinking about is you've got to think really hard in advance about how you're going to process the outputs from those logs. If you just spew out lots of text from your log files, you're going to be there forever processing it afterwards. Best thing to do is to output comma separated or tab separated text files that you can import straight into a spreadsheet, and you're off in your analysis. Time, date, stamp them automatically so that you can tie them back to your forms, which are also time and date stamped, so you know whose log file is whose without having to worry about naming the log files, so you keep it all anonymous. Big rule here. If you're running multiple studies, you're going to have multiple days of user tests. Check nightly that your log files are correct. First day you do it, have 1 or 2 people do the study, check that night that your log files are all okay. Ideally do some analysis of them that night to make sure everything is coming out as you expect and they all look good. You don't want to spend a week doing user studies and then discover your log files are rubbish. So check them nightly and back them up. My tip is to stick them into a 7Z archive on Dropbox or Google Drive or Microsoft Cloud. Stick them on a cloud server. 7Z archives are good because you have to open the program and delete things inside them. Zip archives are a bit dodgier because it's just a bit easy to double click, open up the zip archive in Windows, and then click on a file and accidentally delete it, thinking that it's your working directory. Because some users might withdraw from the study, some log files might not be suitable for one reason or another, so you might end up deleting log files, like you might test the system, so you have to delete your test ones. You do want to do that from a copy. You don't want to do that from the original. All your log files that you get, you must stick in your archive and keep them there and don't delete them so that you can always go back to them when you accidentally delete the wrong one. Sorry, been there, done it, horrible, don't want to do it again. Whew. You might also want to take video and photos during the session. You might also want to take audio recording, but actually taking notes yourself is quite useful. Having video is sometimes helpful. If you see a real anomaly in your data, you can go and look at the video and try and see why that happened. But for A/B testing, it's best just to take notes. But actually, it keeps it all simple and smooth. And that's about it for this video. In the next one, we'll look at simple statistical analysis.